Hello and welcome to the Expert Series. I'm Antonio Blanco and I'm joined today with Greg Black, and he will be talking to us about the use of thermal cameras in predictive maintenance. Welcome to the show.
Hey, thank you, Antonio.
Yeah. So in your opinion, why is it important for electrical and predictive maintenance professionals to use a thermal camera?
Electrical and predictive maintenance personnel are in charge of the system. They're the eyes of the system. So it's up to them to deliver accurate reports. So a thermal camera is going to do a couple of things for you. First of all, it's going to make your decisions more accurate. You're able to see and make better diagnosis of your equipment. You're able to isolate problems faster. Mm-hmm. You're able to isolate problems that will help you save time. They're cost effective because now there's not a whole lot of time for you to make a decision. Plus you have the visual feedback that you need, that you instantly see what the problem is. And overall, you're going to be more confident in delivering that report. And bottom line is, the more accurate the report is, the better the decision the people above you can make, because it really is, how much is this equipment going to cost me if it runs to failure? So they're going to look at that, make some decisions about cost, because it is about money.
I see. So talking about money, how does a thermal camera help you save your clients or your customers money?
I'm able to show them, we have what we call levels of criticality. So I'm able to make a decision once you learn how to use the camera. I'm able to make decisions about where that thing is and where that piece of information, where that equipment is, where it's ready to fall apart, ready to burn up, ready to fail. And from that, do I have to send people home? If I'm running this organization, this company, how many people do I have to send home that day? How much is my downtime per hour? That's what you really want to know. That's the information you want to deliver to those who are running the company.
Sounds like using a thermal camera could really save a tremendous amount of money. I mean, what kind of money are we talking about here? I mean, can you give us some examples of maybe the kinds of savings that a thermal camera would enable you to provide to your customers or clients?
Absolutely. In the utility, one of the pieces of equipment I was able to identify was a 33 MVA station class transformer. So 2 months before that, I did a baseline and then went back and checked on it. There were some other indicators, but the thermal camera is the one that really locked it in. And I was able to go to engineering and say, hey, you got a transformer here that may not be long for this planet. All right, and they didn't take that information very well until the fire department showed up after it blew up. So that station class transformer was almost $4 million to replace. And that was just the transformer. That's not the cabling, that's not the insulators, that's not the getaways, that's not the cleanup at the substation, because you just don't put water on electricity, you got to use foam. Mm-hmm. Okay? At least this fire department did. They put foam on it, so you had all that stuff to clean up, plus system downtime. Mm-hmm. Then you had to call crews out. And so just basically, the hardware equipment itself was $4 million.
$4 million.
Yeah. Right.
So that with, like you said, cleanup, downtime, I mean, you know, maybe up to another $1 million in inconvenience, so $4 or $5 million. And if they would have heeded your advice, or if they would have heeded the report that you provided to them, what would have been the outcome in terms of dollars to replace or repair that?
If they had to replace anything, I think it would probably been the area of somewhere around $250,000.
Okay.
You know, and then the best part is they would have been able to schedule an outage and then assign a crew to take care of the parts replacement and repair. Then it wouldn't have ran to failure. In the middle of the night, there's this massive explosion, and then fire department's showing up. So being able to just go through and say, hey, we need a crew, and schedule that crew. They could have did it on the weekend. Yeah, you got to pay overtime, but still, even with the parts, it's not $4 million. Even with the parts and pieces and everything that's there, it wouldn't have been $4 million. Plus, you know, the neighborhood that transformer was setting in, those folks were a little kind of terrorized when you had something that big blow up. They thought there was something else going on, that, is this a terrorist? What's going on? So they were a little skeptical about what was going on. But you're able to schedule it. And anytime that you can schedule an outage, it's going to be way more effective than letting it run to failure. Because you never know what other pieces and parts are going to be in that bottom line.
Right.
Because we always forget something. How many times you go in a grocery store and you got your list, you get home, you go, oh, I forgot something.
Right.
Same concept.
Right. So do you find that this kind of situation where you can identify a problem using a thermal camera prior to it running to failure, is that a common theme in the use of a thermal camera in predictive maintenance?
Well, let's look at motors, for example. You can look at the windings on a motor, and there's always a mechanical. Every motor has some mechanical bearings or shaft either inside the motor or it's connected to something so the motor does some work. All right, so there's a mechanical connection somewhere always there. And you're able to look at that. You can determine if the bearings or in the end bell are getting ready to go bad. You can see if the shaft alignment is out. You can see all of that. And depending on what that motor is running inside of your facility, you got an answer right now. You can take a picture, create a report, and go and show some folks, hey, this is important to our process. Let's put some eyes on it. Let's get some folks behind it. Let's get this repaired as soon as we can.
It seems also that it's much easier to advocate your point to the decision makers and the stakeholders in a company when you have visual evidence of a problem as opposed to just a temperature reading, for example. I think you had told me previously how you got into thermal cameras, where your interest came.
Yep.
Can you tell us a little bit more about how you got involved with thermal cameras?
So how I got into the thermal camera part of this whole thing, I used to carry a little infrared thermometer, and it had a little digital readout. Of course, it had infrared thing on, put special glasses on, and I was shooting bearings and alignments, shafts that I was just talking about. And so I would get a reading off of that. And one of my supervisors said, well, I think there's a guy here somewhere in the organization that's doing thermal imaging. So I went and talked to him and I said, hey, why don't you come out here and take a look at this? And I was looking over his shoulder and he shot this particular motor, and yeah, the bearing on the end bell was going bad. He goes, oh, that doesn't look good. But he was in a whole total different section. He was kind of in the environmental section. And I said, well, maybe we need to migrate this over into where there's heavy electrical use. Not only the utility did water, pump stations and transmission stations for water, as well as transmission and distribution of electricity. So he said, I think this might work better over here as well. So we had a chance to get eyes on, and that's actually how I got in the middle of this whole thing.
I see. So what advice would you give other potential users of thermal cameras involved in predictive maintenance or heavy electrical environments? Do you have any tips or tricks or things that they need to look out for, or things they need to pay attention to? What would you say to them?
Well, first of all, I would say you got to get into the theory and into the technology. This is wicked crazy stuff, and it gives you answers that you don't have to guess, because picture is worth 1,000 words. So if you're able to deliver that to a customer or to an engineer or to somebody that is questioning what is going on with this process, you're able to give them clear answers. In very few words, you could show them this is exactly what's going on. So what I would recommend is that they find a way to have, whether it's a little device that plugs in the bottom of their iPhone. Again, that's going to have a certain range, 3 to 5 feet. That's all you're going to get. And then if you are into heavy industrial or any mechanical stuff, heating, ventilation, air conditioning, all of that stuff, the camera that you purchase is going to be more suited to giving you better information because the resolution of the camera is better.
It seems like if you were to have, in the case of the $4 million transformer, if you were to use a small, inexpensive solution, that might not be appropriate for the level of liability that you're accepting, or responsibility that you're accepting as a PM. So can you speak to maybe particular camera features or camera types for people in your position, like in more complicated environments? Are there things that they need to know? I mean, do you have recommendations in terms of camera capabilities?
If you are in utility or you're doing any of the IR scans that involve a lot of large pieces of equipment, you want the best resolution you can get. 320 by 240 or better is going to give you a better information palette that you can select from. It's going to give you better resolutions. It's going to give you a better range of criticality. You're able to establish how this piece of equipment is performing over a period of time. So 320 by 240. Also, you want to look at the range. What's the distance on this camera? So if you're shooting overhead, cross arms, insulators, you want something that's going to reach probably 20, 30 feet. That's going to give you good information at a 1-inch spot, size of your thumbnail, 1-inch spot in about 20 or 30 feet.
Okay.
So you want to be able to get clear information that is going to give you that. So those are the cameras that you look at. If you are just kind of doing automotive stuff, or you're just kind of doing small electrical panels, something 3 to 5 feet, a little small, almost anything will work in that range. There's less personal liability when you're working in smaller range. Not saying that electricity isn't dangerous, but there's a certain amount of risk you can take if you're 3 to 5 feet away from a panel that's your residential panel, 240 volts at about 200 amps. Yeah, you're okay. 3 to 5 feet in front of that panel, you're going to see if there's a bad breaker.
So like a residential electrician might be able to get away with a plug-and-play type camera, but when you move into utility work or you're working as a predictive maintenance or electrical professional at that scale, you definitely need to scale up to, what would be like consider a professional series style of camera.
Something that's going to give you better resolution. The key here is resolution and range.
Okay, and how do you achieve that? I mean, what kind of things on a camera would you be looking for to achieve that? Optical range? Is it optical zoom? Is that what you're looking for? Or lenses? Or
Well, I tend to stay away from optical zoom because our eyes don't zoom. Okay, you have to walk to that. So you want a lens that you can put on that's going to give you that range. A zoom is going to make it a little fuzzier, and it's going to let in more reflective temperatures because you're zooming out and that image is going to be softer.
Okay.
So you want to be able to put on a lens, or if the camera has that capability of being able to reach that range, that's what you're looking for. You want the best resolution that you can get in whatever camera that you have, and the range of that camera. Those are the two things you really want to be conscious of. So, you can call people up and say, hey, can I road test that camera for you?
Oh,
and
yeah,
most of
right.
them will let you do it.
Right, for sure.
And
They'll do demos and so forth.
And that's
right.
one of the best ways to figure out what camera do I actually need for the purposes that I need to use this camera for. That way you're not guessing. And then it doesn't cost you anything. You can actually find the camera that's going to suit your capability, and most important, it's going to fit the wallet of people that are getting ready to buy that camera.
Right. Yeah. So maybe to summarize, what are the 5 key points that you feel a thermal camera covers and changes the game with respect to maybe somebody who hasn't used a thermal camera? They don't really understand what they're going to experience using a more enhanced tool like a thermal camera in their predictive maintenance environment.
Okay, well, one thing is that you just don't go and buy a thermal camera. You could, but having training is part of that. That's one of the key things, because you got to know what it is that the camera is supposed to do. Kind of like I gave you an example. If I gave you the keys to my car, yeah, you could find the ignition, but where's the windshield wiper? Where are the lights? How's the radio work? Where's the transmission? You need to find all that, and so training does that for you. It opens that door so you can get in and actually drive the camera, so to speak. Then from there, it helps you isolate those system problems. All right, it's faster. It's non-contact, so you don't have to put your hands on. You don't have to really reach in unless you got your PPE on. You don't have to reach in and put amp probes in. You're able to actually see what's going on. And then your reports are more accurate because you have information. You're given information that's visual.
I see. I see. So you brought up training. How important is it to take classes and learn about how to use a thermal camera? I mean, is that important?
I think training is important because it gives you a certain amount of information and credibility. All
Okay.
right. So with training, at each level of training, you get more information about the camera, its uses, and also where you can't use the camera. That's just as important as knowing where you can get information and where it's out of boundaries for the camera. So you know the camera will operate in this range. And if someone is asking you to shoot out of that range, you can say, nope, it doesn't work over there. It works here. So having the training gives you a certain amount of information, certain amount of confidence, and the ability to deliver accuracy. And that's kind of what we have to do in this business. Everything is quick, dirty, fast now. We want to be able to be accurate. Even we're still human and we still have some errors, but we want our errors to be in the 90+%. And so having certification does that. And then having recertification. And I would encourage people to always read the folks that are always putting out information, other thermographers that are always putting out situations. There's more than 20 applications for this camera. Somebody's writing something all the time. And you have to be eternally curious.
I see.
About reading other things, because the more you know, the more you know.
So you find that there's a good community, there's good community support, good information out there that helps you learn even more.
Yeah. I had to do it myself. Okay, so I had to reach out to other people and find those other organizations or find other thermographers that had different experiences than I had and read some of the things they wrote, you know, and understand how this camera can work in many areas. And that's what you have to do. You have to build a network to enhance your understanding. Yeah, you know, like become a journeyman electrician. That's the start of becoming an electrician. Because they trade you in trade school, they train you, you get out of trade school and you find a problem, you go, oh my God. So the key to being a journeyman is, how do I find an answer? And that's why I'm encouraging thermographers to start building those networks, reaching out, because somebody has a different experience than you have.
Oh, I see.
And that some of them write about it. And if you see something that's different than what you ran across, read about it, because it enhances your ability. And might even say, oh, I didn't know the camera did that. So now you got some more stuff. You know, you got more information. And again, the more information you have, man, the better you are.
Okay. So what about misreading thermal images? Like I've heard that, you know, if you just get a camera, you just go out and you just start poking around and pointing it at things, it's easy to misread the images.
Yeah.
Can you speak about that and maybe the influence of training to identify what actually is going on there?
Yeah. Well, that is the key for training, is to understand what the theory is behind infrared thermography and to understand how the camera works. A lot of guys just grab a camera and go, oh, hey, I saw something here. Well, is the camera set up? You know, if I gave you the keys to a Formula One race car, you're going to like, oh, you're not just going to go out there and mash that throttle and see how fast that car is going to go. You
Not
have
for long.
no idea how it's going to handle. And it's the same concept, you know, pretty much the same concept. So you have to know what it is that you're looking for and understand the technology and the theory. It's the theory behind it. So getting certified and gaining that theory is what happens. You absorb that in, and then again, once you absorb it in, there's always some new changes and some new updates. You know, your cell phone, you get a flag and say, oh, hey, it's time to update my cell phone. There's something new came out. So you want to stay on top of the technology as much as you can.
So So, Greg, can you tell me some stories or some experiences you've had using thermal cameras in your occupation or outside of your occupation?
I have so many, it's ridiculous. How much tape you got?
Just unload on me.
Well, let's go back to the transformer that blew up. That was one of them. That the information was there, it was accurate, and I really was hoping they were going to take care of that. But then again, it was out of my hands. All I had to do was deliver it and say, hey guys, here it is. On the water side of the utility that I work for, they took advantage of it almost immediately. If they saw a bad bearing, if they saw a bad shaft alignment, they had their mechanics out there pulling motors. I was there to unwire it, and wire it back in, and then run it, check it. It was great. So they very rarely ran to failure. I had another customer that called me in, and utility actually provided this service to customers because utilities are kind of like drug dealers. We're selling electricity on bugs. We're going to keep those meters spinning. So we're kind of a drug dealer. So
you're saying that generally speaking, utilities are encouraging excessive energy use.
Well, not excessive, but it's like electric.
But it's a product, right?
It's like electric opioid use, when you ain't got electricity, you can't get your cell phone, you can't watch Netflix.
Yeah.
So we're all kind of addicted to electricity.
Right,
so,
that's true.
We have to have that electricity. Mm-hmm. So if you're running a company or a corporation or whatever, this guy and the utility was sending me out to just do stuff for customers because they say, hey, we got a problem. And this one particular customer kept saying it was our overhead three-phase bank that was causing them problems. I said, okay, let's go in and let's take a look. And this is where, again, training and certification comes in. So I asked him, what is the one piece of equipment that is going to cause this whole place to shut down? You send people home. He looked at a three-phase, 480 volt, about 4,000 amp disconnect. So that piece right there is going to shut the whole place down. It's okay, let's take a look at it. So I took a look at it, opened it up, and because I'm an electrician, I can't open cabinets. And I looked at it, and I had the IR camera, and I looked and I said, you know what? Again, this is where certification and training comes in. And I'm looking at the top of these fuses. I'm like, the problem's not here. Let's go outside. And I went out and I looked at his service connections with the IR camera. He thought it was the transformers, which were about a block away. He thought it was the transformers that was causing the problem. It was actually the connections themselves that were deteriorating. And I was able to see it with the IR camera, had him look over my shoulder, and we're looking up. There's your problem right there. So it's radiating down inside, and you think it's that disconnect or you think it's a transformer. It's that.
I see.
So call electric company, have them come fix it. When they get it fixed, call me back, and I'll come and check it.
Right.
Okay,
right.
make sure they did it right. They got it. They thought it was fixed. Part of it was. He called me back and goes, "We still got a problem." I went out and looked, and the molds from where the electricians had poked the wires in, one of them forgot to tighten it up. He might have got distracted or something else, but
I
he
saw
poked
that.
it in.
Yeah, we have an image of
yeah,
that.
he
right.
poked that in, but he didn't tighten the set screws on it. And I said, well, that was the problem because it melted it again.
Oh, man.
I said, call your electricians back out here again and put another mold up there and then call me back. Third time, beautiful.
Right. You also, I remember you showing me some images of a three-phase transformer that was about ready to blow up.
Yeah.
Yeah. Can you tell us that story?
I think that was a regulator.
Oh, was there? Oh, okay.
The regulator wasn't
It was
circulating.
humming.
Yeah, it wasn't circulating. So you could see with the IR camera how warm the actual regulator was, and it was above temperature that the fans would kick on and start circulating, and they weren't circulating.
Oh, okay. That's that was a different one. But yeah, no. Tell us the story about that. That in that case, you could see that the coolant wasn't circulating through that. I think I was thinking of the image where you were called out and the transformer that outside of the building was just hot, like hot to the touch, and that the casing was hot, and that you were concerned that that was going to blow up.
Oh, that was during one of our growing agricultural marijuana businesses that we have here in Oregon. And that transformer, originally the utility had scheduled a certain amount of amperage for that place. And that area of town had normally been folks that had done woodworking or little small businesses. And as soon as they said it was okay to grow those crops, they just took off. You know, so the transformer was a 300 kVA transformer, you know, and when I walked up on the transformer, some of the other things that you learn in this industry is if you hear overtones or you hear a really loud growling transformer, and I do carry a sound pressure meter sometimes.
Oh, wow.
I'm like, oh, this thing here is above 90 dB.
Oh, wow.
You know,
That's
and you
really
can
growling.
hear, yes,
That's
you can hear it
growling.
along.
That's like a muffler. It's like a
"Oh."
car.
Yep. So, and I was about 25 feet away, and I turned the camera on, and I looked down and went, oh no, it's not long for this planet. So I called a line crew supervisor. So you got to get another transformer out here. So they had to go to engineering. Engineering had to look at the load in that area again and then bring in another transformer. And they changed it that day. That was one of the reasons that the IR camera was useful. That was one of the main reasons, being able to see that in advance, and also using another tool, because sometimes with IR you have to have another tool like an amp probe or a voltage meter. I use a sound pressure meter on transformers. So I had other pieces of equipment that helped verify what the camera was seeing. Okay, so eyes and ears are working both.
Right.
And they got out there that day, and they got a crew. They got everybody scheduled, and they told these companies, we're going to pull that transformer tonight. And those guys were done by 7 that evening.
Oh, wow. So speaking about transformers and range, and you know, I guess a regular pole transformer, it has a certain temperature that it can't exceed, otherwise it's going to fail. And I know you've had experiences where you've been able to see that from the ground, and instead of having to utilize a cherry picker or something else to get closer. How has using a thermal camera changed the approach to overhead bus connections or overhead out of range equipment? How has thermal cameras helped you with that?
So one of the things that the utility was doing was we have ways of putting CTs, current transformers, and the new wave of current transformers actually will go on the transformer itself on a pole, and it will clip around, and you could read the readings. You could basically read that person's bill, Wi-Fi.
Oh,
Okay, and so they would say, hey, here's a location, here's a pole number, go out and IR that transformer, that whole bank, and let's see what it's doing. Okay, so because the kilowatt per hour was exceeding the transformer range, I was able to go out, put my telescope lens on, look up there and go, oh, yeah, we got something ain't long for this planet. Yeah, and then from there I can take those images back and go to the line supervisor and say, hey, you got to get a crew, pole number such and such, here it is, here's what it looks like. And they go, oh, and sometimes they say, well, that's the third time we've changed those. I'm like, yeah, okay. It's easier to change it now while it's daylight than to wait till the sun rises in the middle of the night when it blows up. Yeah, so yeah, there's a lot of things that the thermal camera can give you information. The training helps you understand what it is that you're seeing inside of the camera. Helps you make decisions. And again, those decisions are paramount to passing that information down the line.
So Greg, let's talk about bottom line here. So how does a person decide on how much they need to budget for a thermal camera?
Right. Well, I think it depends on what is in your process. What is in your company? What are you looking to do with that thermal camera? What are the ranges of, I said it's over 20 applications. Which of those are you going to use this camera for? If it's just for coming out of the bar at night and looking around to make sure nobody's going to jack your car with a little plug-in in your phone. So what is it that you're going to spend? Where will this camera give you the biggest return? All right. And so you have to look at your company process or look at whatever organization or whatever freelance contract work that you're going to do. You want a camera that's going to fit that budget. All right, and give you the best information, the most accurate information, and information that you can be confident when delivering a report. So that's how you kind of gauge the budget.
Okay. So we could also talk about return on investment.
Mm-hmm.
So obviously in a situation where you have a $4 million transformer that could fail, and in that particular case did fail, there's no, if you had spent $1 million on a thermal camera to prevent a $4 million failure, your return on investment would be almost instantaneous.
Exactly.
There aren't really $1 million thermal cameras that we're going to be really using in this particular situation. So the sky's the limit in that particular situation. But I guess, would you agree that the return on investment is also dependent on the level of liability or your responsibility in your job? Or how would you?
The liability, we all assume a certain risk. And I'm sure that we take those risks every day. And with those risks, we make choices about what it is that we want to do and what is our capability and what is expected of us inside of those parameters. So once you sign on to doing thermal imaging, I feel like you have a responsibility to be the best that you can be at what you do and search the information that you need to have and to be able to deliver the most accurate piece of information that you can. Mm-hmm. There's not much more that can be demanded of you. You are the quarterback of these systems. You are the guy that they will call and say, what do you know about this piece of equipment? What do you know about this system? And you're in that. You need to deliver some answers. Mm-hmm. And I don't know is not a good one. Mm-hmm. But if you say, I don't know, but I will find out, that will give you a little more running room, a little more breathing time. So you want to be the best that you can be at whatever it is that you're doing for your company, because they depend on you. Mm-hmm. And a whole bunch of other people depend on you too, because they have car payments and lights and food and soccer and all the other stuff that your paycheck goes for. But you want to be the best that you can be at delivering the information that says this is the quality of our system. And infrared gives you the opportunity to deliver that. Say, this is what your system looks like. So inside of that, part of the training is a level of criticality. So if you are invested in the thermal camera, you will find an opportunity to create levels of criticality and share them with people. Share them across the whole organization that anything above 40 degrees centigrade is going to be a problem.
So we're talking benchmarks. So you'll be able to use the tool to create benchmarks for the equipment and tolerances. And I see.
Yep, and then from there they can make assessments and say, hey, it's not 40 degree C, we're okay. We can start planning for that. Maybe that's the next year's budget, capital work, or whatever you call it. We're there, okay? But if it's 40 degrees C or above, and outside temperature is 37 degrees Fahrenheit, you may have a problem that's getting ready to happen.
Right. So you can also identify trends too.
Yes.
So you could create a benchmark, for example, and then you can watch this thing and it just is moving along and it's creeping up, and then it's starting to creep up faster. So you could predict, obviously, that's why it's predictive maintenance.
Right. Yeah.
So you
can look at the slope. And again, if you're the quarterback of that system and you're personally invested in that system, and you say, hey, I found this piece of equipment, I'm going to start trending it. Camera does that for you. You can go out, and every time you shoot, you notice something, that slope starts to climbing. You go, I got to let somebody know. Yeah.
So have you been able to predict, down the line based on a trend, like creating a trend to say, okay, well, this looks like it's got, according to this slope or this graph.
Oh, yeah.
Yeah, is that something that?
Oh,
yeah.
yeah.
So,
yeah.
okay.
More than often, I was able to do that quite a few times. And there were guys that were listening. A lot of times, again, I'm talking utility, the underground crew was able to see that because a lot of the connections, the elbows that they use on a lot of the transformers, you could see them starting to, you see that insulation, that rubber insulation that's around that, you could see it starting to break down. And then you could start trending it. You can actually create dark, dots on a chart. You can actually just phase it out and say, hey, here it is. And they can say, okay. And there are specs on those elbows, by the manufacturer that says above this temperature, yeah, we got a problem.
Right.
So, and they were able to change them out. As soon as they saw that and they saw the trend starting to go, okay. But what was cool about that is that the transformers from that same era, okay, this utility's been around over 100 years. So the transformers that were the same vintage, once I found one of them that I was able to start charting and saying, hey, the elbows on here, they went back and looked and go, all the cables that went to all of those transformers in that area from the same era, let's just change all those elbows. Because if that one is beginning to fail, they are all the same vintage age. Let's change them out.
So you could effectively prioritize maintenance schedules.
Yep.
So that's essentially what you do. It helps you do your job.
Yep. Well, it helped me create some opportunities that they didn't run to failure by going, oh crap, this thing failed. So they're able to look at the whole thing because a lot of this utility, things were built in stages over the years. Some of it was fairly new equipment that came from, the Starship Enterprise, and some of it came from Buck Rogers.
Oh,
So you got those bookends between all this equipment. And I'm sure there's other facilities, that other folks that might be watching this will see that there are trends of where things have migrated and changed. And that's why it's important to stay up on the camera because things change. Things change.
So what do you think about all of the new cameras? Like it seems, do you feel like we are in a situation now where the equipment is really available to everybody? Like maybe 10, 20 years ago, the stuff that we have in our pockets was tens of thousands of dollars. Now you can pretty much put that technology in your pocket for, I think there's a $199 addition to a phone that you can use. So I mean, it's really available for everybody. I mean, where do you think people should jump in on this, or should people sit back and wait, or what do you think? What's your opinion on that?
Antonio, my mother's going to be mad at me, but I was born too soon. Okay, the way the cameras are going from where I have seen them, I've been in thermography for 12, 13 years now. Okay, so I was born too soon. The technology where it is now, it's getting ready to blow up.
Oh, okay.
Okay, so I'm saying get in where you can get in. Because sometimes people go, well, I'll just wait. The price is going to drop. Get in where you can get in. All right, get in, suck in that information that you need to know, and put skis on because it's a fast ride.
Yeah, you could really probably establish yourself now while it's still in a. Not everybody's using it, for example.
Exactly.
And establish yourself, professionally.
Yeah.
In terms of your credentials or.
Yeah.
Yeah.
And what's cool about all the camera stuff now is, it's just a lot of people see it as this hocus pocus kind of magic thing that's out there, and those of us that are in the middle of this, we're going, oh no, this is going to change your life. Okay. This will change your life. This will change how much money you spend. This will auto-correct everything that you guessed at, because guesswork is no longer part of the issue now. We know what's going on.
Yeah.
And so that's what we're trying to change now. But we still have some pushback. As I said before, we as humans, we hate what's new. You know, so we got new technology, and we see it all the time, and we see it advancing. It's like a beast on the avenue. One step is larger than the next one. It's further. We see it coming, and it's like, hey, y'all need to get on board with this because it's great information.
Okay, so with that in consideration, I know there's people out there, there's other professionals, other predictive maintenance people out there that are thinking, you know, how do I convince the directors in my company to invest in this? I mean, they know these people, these professionals, these electrical professionals or predictive maintenance professionals that are there, yourself included. I'm sure you ran into this situation. They are advocates, but they need to they need to be able to formulate a message to their directors, for example, that would help them convince the stakeholders, the people that assign the budgets, that investing in thermal technology is such a no-brainer. I mean, the return on investment, the safety, the increase in safety, the increase in efficiency, time savings, downtime savings. What is the message? Talk to the stakeholder, talk to the director, and let them know what is it that they need to know.
Yeah. Well, I think there's a couple of ways you can do that. One of the best ways, I think, is to, let's say you want to try out a camera, and you know, let's say you have an existing camera, and you want to try out a newer camera that you think the company should have. All right, so one of the things you can do is invite those people to come to your next series of scans, next thermal imaging scans. All right, invite them to come and look at what is going on, because then they will be exposed to the same information that you're exposed to. And I think it would help them understand what it is that you do as a predictive maintenance person, but also gets them involved, because now they have to come and see what is it that you do. And then you invite them, come on, let's go look at this transformer, or come, I want you to see what's going on with this. And then bring them out of the office or wherever they are counting their beans. You know, and bring them out so they can see what it is that you do, and see what information that you're gathering, and see how different it is. So let's say a 3-phase overhead transformer bank. So you know, the meter people have said, hey, go to this location, here's this pole number, these cans on the pole are getting ready, they got something funky going on. So you invite, hey, come on, get in my truck, let's go. And you go to a one that doesn't have problems, and you shoot a scan of that. You show it to them. That's normal operation. Let's go look at one that's getting ready to be overloaded. You go there, shoot that one, A and B. Then they see, they go, oh, that's what you're doing. Yeah, that's what I'm doing. So now let's go back to your office, and let's count the beams on this bank of transformers, that if it was to blow up, what is it going to cost you to replace that, and then that customer that's out of power. Because again, we're on-bug deliverers. We're electrical opiate deliverers. You know, we're supplying you with that drug of little blue sparkies. You got to have them. Your stuff's not going to work. And so that's one of the ways to do it. Another way is that you can internally build advocates. You can get people, talk to people, and say, hey, look, this is what the camera does. And again, it is all about hands-on and getting them to get involved. Come go with me. Come go with me. Don't sit there and look. Come go with me. Let me show you some magic. Let me show you what this hocus pocus is about. Yeah.
Oh, cool. So for somebody sitting on the fence right now in terms of their next move, what do you say?
Well, I'd hope it's an electric fence that you, no. If they're sitting on the fence, and you know of some thermographers that have information, or you can go to a website of folks that are selling thermal imaging or doing some kind of training. Take them to that website and have them look at it. But don't just send them there. Don't say, hey, I'm going to forward you this link through email. Go up there and say, hey, I got this link. I want you to look this link up. So you're there physically able to explain to them what's going on. Because a lot of times they're just going to look at it and go, oh, yeah. They might watch it for 30 seconds and go, oh, yeah. you know, and they don't see how they fit into that whole piece of the puzzle. All right, they are a piece that fits in, and you want to get them involved into fitting into that whole puzzle.
So Greg, you're a level 3 thermographer, and you're certified and you're trained to use a thermal camera in your profession. Can you take us along that journey through your certification?
Yep. So, you know, sometimes you ask the question, why is certification important? And certification is important because it's the evidence of you having gone through the theory of infrared, having worked with the cameras, having created reports, having done the mathematical process of understanding how thermal imaging actually works. So it's your evidence. That's what certification is. It's evidence that I have spent time with this camera and understanding what this theory is. So part of level 1, level 2, level 3 is there are labs, and I found the labs to be interesting because there's all sorts of little things that they teach you to look for to help you gain real world experience. That's what I'm looking for. So looking at the labs, we become conditioned to look for things and understand what we have to do. As I would always say, they teach you how to think, not what to think. And it's been that way at every level along, from level 1, level 2, level 3. Level 2, in order to get your level 2, you have to create a project. You have to go and thermally shoot something, write a report, and then have to make sure that the numbers, the actual mathematical theory, lines up with what it is that you're trying to present as your project. Right? Same in level 3. Level 3 is a little more intensive, and level 3 means you actually have to write some kind of report or some kind of condition that speaks to your place of employment, or if you're going to freelance or whatever you're going to do. These are the things that you need to do. And it's about a 30-page deal. It could be longer, but minimum 30 pages. And you've got to have what information in that if you had to go to the director of that company, you can say, here's a program that if you guys were to follow it, it could save you money. That's what the level 3 was about. And again, I found more information in level 3. I know some level 2s that go, I don't want to take level 3 because level 3 is pretty hard. Yeah, it is. But the information that comes out of that gives you about a third more information than if you had just doing level 1, level 2. Level 3 is a third more information. And a third is a lot of information.
I mean, just in terms of using the equipment,
Using
right?
the equipment and more things to be aware of. They really dial in on more things that you need to be aware of. And it's kind of fine-tuning things too. So you are aware of a lot of things that you didn't get in level 2 and level 1. Okay, level 1 kind of opens the door, and I remember being sort of intimidated, like, will I ever learn this? Because it is hard. You got to have some skin in the game. It isn't one of those casual things that you go, well, yeah, I'll use it every now and then. There are people who do. I find myself making excuses to turn the camera on at any given moment, at any given time. Here's one of my B-52 stories.
Okay.
So we built our house, and here it is, fast forward 25 years later. And every end of August, first part of September, there is this ant colony that comes out around one of the places in the sidewalk. It comes out, thousands of ants crawling out, and they're, getting their wings and are flying off. I'm going, what the heck is that? So pulled a thermal camera out one night and looked, and the foundation wall is warm.
Oh.
Okay. And it, then it's, nighttime is around 35, 40 to 35 degrees. I'm going, why is that wall? And there's ants always coming out of there. So I go in the garage and look. We have a chest freezer that we moved in. For 25 years. I created a microclimate for the ants
Oh, wow.
And so for them, it was South Florida all year long. They're like, hey, you know.
We're going to Greg's place.
Yes. So I had created a microclimate that I didn't know that the compressor off of the chest freezer had warmed the stem wall all the way down. And the ants were like,
Yeah, right.
It's beach
South
party
Beach,
here.
Miami.
Who knew? But again, that's one of the things I discovered by having the walking around thermal camera, plus having the information is what did I do, and then being able to extrapolate and connect the dots. That's why the ants are always coming out of there, is because it's always South Florida there. No matter what the rest of the winter is, it's South Florida. So man creates environment.
Right. So with level 2, you took it to the next level, obviously. So what is your recommendation in terms of other people that are considering certification? Like what kinds of things do they need to be considering in order to move in that direction?
I think that's a fair question, Antonio. I think it's up to that person. You know, some people, I'm an extreme person, so I want to run it all the way out to the end until the last cow comes home. You know, and so I'm that kind of extreme person. But there are some people who just need enough information to do their job, and they're fine with that. You know, and there are other people who want to have a little more understanding, especially if they're going into business for themselves or doing, let's say, building envelopes. Okay, I need level 2, and other pieces of equipment that go along with doing building envelopes and you know, making a living for themselves doing that. I'm an extreme guy. I want to, like I said, I want to run it all the way out. If there was a level 4, I'd be in that class too. You know.
So do you find that being certified has opened doors or created opportunities for you?
It has. It's created a lot of opportunities. Gives you a little bit of street cred too, you know, because they say level 3. What does that mean? You go, oh, you know, and then you start talking, and the people start either their eyes glaze over because it's too much information, or they go, oh yeah, oh man, and then the question is, hey, I'm having this problem. Can you come by and look at this? Yeah, I can come by and look at that. It's not a problem. You know, so those are the things that happen, and so being level 3 means you can pretty much explain things. So you want to educate the people that you want to do work for. You don't have to make their eyes glaze over, but you want to give them enough information that they can understand what's going on. And if they're looking over your shoulder while you're shooting something and they ask you a question, what is that? Let me explain that to you in the report. I'm able to really sit down with you, and I'll print out a report, and we'll really look at this, and then we'll make some decisions about what's going on here. But right now, I'm in the middle of scanning. Let's go with that.
So with respect to reports and software, do you use software? And like, so you can take scan, and then you can go back to your office, and there's software that helps you analyze your images and then process that. And so can you speak to the usefulness of the software, or do you have any comments on that?
Pretty much the one that I've been using has been FLIR Tools Plus. And you kind of get that when you go for training at ITC, and you kind of get that. And I'm sure there's other software out there, but I haven't been exposed to that yet. And for what I was doing at the utility, that was fine. You know, that I was able to do the levels of criticality, create reports, able to do the charts and graphs and deliver stuff. I was able to do that, and it was fine. However, in level 3, I got an opportunity to get exposed to researcher software.
Oh.
And that's a whole other curve. And that was kind of an addiction.
Oh.
Using the researcher software, because you could still use your same camera, but you had a whole lot more tools to monkey with.
Oh,
and,
I see.
You know, it was like, yeah, you know, so I'm one of those guys, you know, ones and zeros, and, you know, I want to be down into every little, most significant bit. I want to be down into every one of those and see exactly if I can tweak that, you know, like painting a 747 with a Q-tip. That's the kind of guy I am, man. You know, to step back and go, yeah, it's all even too. You know, that's the kind of guy I am, man. So,
Well, cool.
yeah.
Well, hey, thank you so much for coming by and
Yes, sir.
sharing your stories.
Yes,
Keep an eye out for more Expert Series webinars and videos. And down below there'll be a link if you want more information, or if you want to contact Greg, we'll have that information provided as well. Thank you very much.